This is lesson 43, B.TECH example 25. And in this example, we'll design an 8-to-3 encoder, the same one we did in lesson 42 using logic equations, but in this case, we'll try to use a VHDL for loop. So here's the truth table we have for the 8-to-3 encoder. Remember, only one of these inputs is 1, x0 to x7, and then the 3-bit output encodes the input. So if x3 is 1, we get a 3 output. If x5 is 1, we get a 5 output. So how can we do this? Well, suppose we take a for loop, say 0 to 7. What's the rule? Well, the rule is if xi is 1, then we want y to be equal to basically I. We have a problem here. Of course, I is an integer. Y is going to be standard logic vector. So in this case, we're going to have to convert an integer to a standard logic vector. Let's see how we do that. Here's the entity for our encoder. X is standard logic vector 7 down to 0. We'll have our usual valid output, and Y is output standard logic vector 2 down to 0. So here's the architecture. We'll make a variable j as an integer inside the process. We have process x, that's our input. We'll set y to 0, all zeros, and valid to 0. And then we'll say for j is in 0 to 7 loop, so we go through all 7 inputs. If xj equals 1, then we want y to be equal to j. But j is an integer, so we have to convert it to a standard logic vector, and we do that using the VHDL function convert standard logic vector. But notice there are 2 parameters here, j, the thing we're trying to convert, plus 3, that is the number of bits we want y to be. Well, y is 3 bits, so we take the integer j and convert it to a 3-bit standard logic vector, which is what we want. And we set valid to 1 anytime we get at least one xj to be 1. So this should work, and we can check it by simulating it. We'll use the same circular 1 counter we did before to get a single 1 output going from x0 to x7, and sure enough, y is 0, 1, 2, 3, 4, 5, 6, 7. So it works.